we're going to continue with 2.4. And today I want to talk about several things having to do with your zeros and the factored form of a polynomial. Okay? So, to start with, let's say I have a polynomial of, oh gosh, let's find a good one. How about 2x to the third minus 6x squared minus 12x plus 16. Now, I know that this has to have 3 factors to it. How do I know that? Because it's x to the third, right? So I can actually factor this into 3, and I'm looking for the factored form. Now, what if I told you that I knew 2 out of the 3 zeros? We have zeros at x equals, let's say 4, and x equals 1. And we want to find the factored form of the polynomial. Okay? So first of all, what we're going to do here is I have 2 of my zeros. I don't have the third one. In order to find the third one, we are going to divide twice in this case, since we have 2 zeros, to find the missing factor. Huh? Just to make sure that you see that part. Make sure that our friends at home that are watching see that part. That's right. All right. So the first thing we're going to do is we're going to do division. Okay? Now, I know y'all like synthetic division better, so that's what we're going to use. Okay, so we're going to do a long one-sided tic-tac-toe. And my coefficients go across the top. I have 2, -6, -12, and 16. The first 0 I have is 4, so I'm going to start there. I'm going to bring down my 2. 4 times 2 is 8. I add these together, I get 2. 4 times 2 is 8. I add these together, I get -4. 4 times -4 is -16, and there's no remainder. All right, so I've done 1. Now I have another 0. So I'm going to go back to my synthetic and continue with my second 0, which is 1. Bring down our 2. 1 times 2 is 2. We add these together, we get 4. 1 times 4 is 4. Add them together, there's no remainder. So now, the first one we had right here, this went from x to the third down to x squared. After that, we divide again. This goes down to x. So technically what we have here is 2x plus 4. So this is one of our factors. So we have y equals our remaining factor once we divided twice. We have the factor of x minus 4, and we have the factor of x minus 1. Okay? That's the basis of what we're doing today. Okay? So, here we go with example number 1. Find the factored form. And let me tell you that we're going to do y equals 5x to the third minus 12x squared minus 23x plus 42. And I'm going to start off by graphing this. This crosses here, and it crosses here. And I'm going to say this does one of these deals. Say that crosses through that point. Drawing's not beautiful. All right, so I see 2 zeros I have up there, right? I'm going to use this graph in order to find my third factor. I know I have 1 0 here at -2, and I have 1 0 at +3. So I'm going to do synthetic division to find my third factor. So my coefficients are 5, -12, -23, and 42. Let's start with my first 0 at -2. Bring down my 5. -2 times 5 is -10. Add those together, I get -22. -2 times -22 is 44. Add those together, I get, I don't know. Yes. 21. 21, thank you. -2 times 21 is -42. And there's no remainder. Excellent. What's the next 0 I want to use? Let's use the 3. Exactly. That's the one we know. We're going to bring down the 5. 3 times 5 is 15. We add it together, we get -7. 3 times -7 is -21. We add those together, and there's no remainder. So our factored form is y equals 5x minus 7. So that's the one we got at the end. X minus 3 and x plus 2. Okay, questions out there? Go ahead. The first one they give to you. Number 25 they give to you. Okay, there's a couple of them they don't. Yeah, if we're finding the factored form, yes. Yep, good question. Yeah, because the graph gave you the first couple zeros to work with because of where it crossed. Okay. Other questions? All right, excellent. So this is very similar to number 25 where you're starting at today. Okay. 27 and 29, they're giving you the zeros. You got to find the polynomial. So we got to do some boxes. Okay. One of the things I want to talk about, so here's example number 2. So this is 27 and 29. Find the polynomial given that x equals 3, 2/3, and 1/2. Now, obviously x equals 3, we know that factor is x minus 3. X equals 2/3. The first thing I would tell you is you clear the fraction, which will give you 3x equals 2. And then if I'm setting it equal to 0 because it's my 0, I actually get a factor of 3x minus 2. Right? If you set that equal to 0, add 2 over, divide by 3, right, is what we usually do. Okay? Same thing here. If I have x equals 1/2, I would clear the fraction first, so I get 2x equals 1, and then I would subtract that over. So my factor is 2x minus 1. Now we're going to multiply them together. Let's do the first two in a small box to begin with. 3x minus 2 times x minus 3. 3x times x is 3x squared. -2 times x is -2x. 3x times -3 is -9x. And -2 times -3 is 6. Again, remember we're going to add our diagonal together. So over here, we're going to do one more box. I like to put the longer one across the top. 3x squared minus 11x plus 6. And I'm timesing by 2x minus 1. 2x times 3x squared is 6x to the third. 2x times negative 11x is negative 22x squared. And 2x times 6 is 12x. Next row, I have 3x squared times negative 1, or negative 3x squared. Negative 11x times negative 1 is positive 11x. And negative 1 times 6 is negative 6. Again, remember these diagonals add together. So my polynomial is y equals 6x to the third. Negative 3 and negative 22 is negative 25x squared. I have 11x and 12x is positive 23x, and then minus 6. Any questions there? No questions there? Okay. We're solid. Let's move on to the next part. Example number 3. Find the cubic function in factored form. Okay? So I'm going to actually give you a table. So let's say I have x and I have f of x. Beginning my table, I have a negative 2, 0. Let's say I have a negative 1, 24. How about 1, 0, and 5, 0? All right, so here's how it's going to work. First of all, you see we have 3 zeros up there, right? So technically, our polynomial is y equals a, because we don't know what our coefficient is on the front, x plus 2 times x minus 1 times x minus 5. Do we all agree there? Okay, so now we're going to take this other point they give us, this one right here, and we are going to plug it in for x and y and solve for a. So I have 24 equals a times. If I plug negative 1 in here, I get 1. If I plug negative 1 in here, I get negative 2. If I plug negative 1 in here, I get negative 6. So I get 24. What equation? Okay, let me try again, unless somebody else wants to try. So you understand where this comes from? Okay, so then the point that isn't a 0, we plug 24 in for y and negative 1 in for each of the x's. So we have 24 equals a. Negative 1 goes in here, we get 1. Negative 1 goes in there, we get negative 2. Negative 1 goes in there, we get negative 6. Okay, so we get 24 equals 8a. So in this case, what does a equal? 3, yes. A equals 3. So then you're going to take that back up and plug it in for a. So y equals 3 times x plus 2 times x minus 1 times x minus 5. Okay? This is what you are doing for 31. Just 31. Suck it up. We got this. I know. All right, example number 4. Example number 4 you already know how to do, but we're just going to remind you very quickly. This is 33 and 35. Use the rational zeros theorem to find all possible zeros. So let's say I have y equals 4x squared, or no, x to the third, sorry, x to the third, plus 6x squared minus 7x plus, let's go 10. All right. Does anybody remember how to find all possible zeros?
Oh, you got to put like your last number and your first number, divide them.
Yeah, so it's all the factors of the last number. So all the factors of 10, which are 1, 2, 5, and 10, over all the factors of the first number, which are 1, 2, and 4. All right. Yep. We're just listing them, though. You don't have to plug them in or anything. We're just listing them. So we're going to start here. Let's go plus and minus 1 over 1 is 1. Plus and minus 2 over 1. Plus and minus 5 over 1. And plus and minus 10 over 1. All right, we're done with that one. Let's go to the next one. We have plus and minus 1 over 2. Plus and minus 2 over 2, which we already have. Plus and minus 5 over 2. And plus and minus 10 over 2, which we already have, right? So now we're done with 2. Now we're going to do our 4. We have plus and minus 1 over 4. Plus and minus 2 over 4, which is 1/2. Plus and minus 5 over 4. And plus and minus 10 over 4, which is 5/2, and we already have. So all you have to do is just list them. Okay? You just got to list them. All right. Last thing I want to talk about. Okay? This is something new to you. Upper and lower bounds. If doing synthetic you divide and all numbers end positive, then that zero is an upper bound. Okay? If all numbers alternate, then that zero is a lower bound. So let me tell you what I mean. All right, here is example number 5, right? Example 5. This covers your 37 through 43. So let's say I have f of x equals 2x to the third minus 4x squared plus x minus 2. And they tell me that my k, or my 0, equals 3. I want to know if this is an upper or a lower bound. Just going to do synthetic division. So my coefficients are 2, negative 4, 1, negative 2. I'm going to put my 3 on the outside. Bring down my 2. 3 times 2 is 6. When I add them together, I get 2. 3 times 2 is 6. When I add them together, I get 7. 3 times 7 is 21. When I add them together, I get 19. So this is an upper, exactly. There will not be any zeros higher than here. Okay? If you do it and your signs alternate on the bottom, then that's a lower bound. Do you want an example of one of those? Okay. No. An example would be something like this, exactly like this, but then maybe it'd be 2, -2, 7, -19. The signs change. Yes. 3? Okay. This one? Okay. Oh, yeah, look at that. Thank you. I can't even multiply. Oh, sorry, guys. Yeah, I obviously can't multiply very well. 1 times -2 times -6 is -12. Yeah, I multiplied wrong. So this is 12a. I divide by 12, and a is 2. Thank you. So this obviously is a 2 in the front. Thank you very much, Marissa. I appreciate that.